Did you know that some plants can move? And no, we're not talking about Ents from The Lord of the Rings. It's easy to think of plants as stationary, rooted in one place, and existing in a state of perpetual stillness. However, the world of plants is much more dynamic than it may seem at first glance. While plants might not sprint, climb, or swim like animals, they have their own fascinating ways of moving. Some plants twist and turn, reaching out for sunlight to fuel their photosynthesis. Others expand and contract, seeking out water and nutrients from the soil. There are even those that snap shut, protecting themselves from the outside world. These movements might be slow, subtle, and often overlooked, but they are integral to the survival and success of these plant species. In this video, we'll take a closer look at 4 plant species that have developed unique ways of moving. From the insect-catching prowess of the Venus flytrap, to the sun-chasing sunflowers, to the day-night dances of the love plant and morning glories, each of these plants showcases the remarkable wonders of botanical motion. So, buckle up for an exciting journey into the world of botanical motion. First up, let's meet the Venus flytrap, a plant that's as intriguing as it is deadly. Stepping into the world of botanical motion, we find ourselves in the company of a plant that's known for its rapid insect-catching ability. This is the Venus flytrap, a plant that is as fascinating as it is lethal to the insects it preys upon. It's a carnivorous plant, a term that might seem like an oxymoron, but in the world of botany, it's a reality. The Venus flytrap, scientifically referred to as Dionea muscipula, is a marvel of nature's design. It has specialized leaves that function as traps, which are triggered by unsuspecting insects. The edges of these leaves are lined with sharp, tooth-like protrusions that snap shut when an insect lands, effectively trapping the prey within. But how does this trapping mechanism work? It's all about touch sensitivity. The inner surface of the leaf is dotted with tiny, sensitive hairs. When an insect lands and brushes against these hairs, it triggers the leaf to snap shut in less than a second. It's an impressive display of botanical speed and precision, a plant's version of a mousetrap. Once the insect is trapped, the leaf then seals itself completely, creating a kind of stomach where the insect is broken down and digested. This provides the Venus flytrap with extra nutrients, a necessary adaptation for a plant that often grows in nutrient-poor soils. The Venus flytrap doesn't just sit around and wait for its next meal to stumble upon it, though. It actively lures its prey by emitting a sweet scent that's irresistible to insects. Once they land, it's game over. This fascinating plant turns the tables on the natural order of things. In a world where plants are often the prey, the Venus flytrap is a predator. It represents the incredible adaptability and diversity in the world of plants, a testament to the wonders of botanical motion. So the Venus flytrap, a plant that's not just a passive bystander in the world of nature, but an active predator. Next on our list is the sunflower, a plant that's known for its sunny disposition and its love for, well, the sun. These golden beauties, scientifically known as helianthus, are famous not just for their radiant blooms, but also for their unique ability to follow the sun's path across the sky. This fascinating phenomenon is known as heliotropism. Now you might be wondering, why do sunflowers do this? Why do they act like solar compasses, tracking the sun from east to west? Well, the answer lies in the heart of their survival strategy. Sunflowers are sun chasers because they thrive on sunlight. Like all green plants, sunflowers need sunlight for photosynthesis, the process by which they convert sunlight, carbon dioxide, and water into food. But sunflowers take their love for the sun a step further. During the early stages of their growth, sunflowers tilt their heads to face the sun throughout the day, maximizing their exposure to sunlight. This movement is not random, but a coordinated dance orchestrated by the plant's internal circadian rhythm, the biological clock that regulates its physiological processes. As the sunflower matures, this sun-chasing behavior slows down and the plant generally faces east. There's a reason for this too. By facing east, sunflowers can warm up more quickly in the morning, making them more attractive to pollinators. So in a way, sunflowers dance with the sun is a two-step strategy. First, to maximize their own growth, and then to attract pollinators for reproduction. Isn't that fascinating? These radiant blooms are not just decorative ornaments for our gardens, but they are also sophisticated solar trackers, harnessing the power of the sun for their survival and growth. So sunflowers don't just brighten up our gardens, they're also quite the sun worshippers. Our next two plants, the love plant and the morning glory, have a rhythmic dance routine that's tied to the cycle of day and night. Let's dive into the world of the love plant, also known as the purple shamrock. This charming little plant has a daily ritual that's quite the spectacle. As the sun rises and bathes the world in its warm glow, the love plant springs into action. Its heart-shaped leaves, in hues of purple and green, unfurl to greet the day. It's like the plant is stretching out its arms in a sleepy yawn, ready to soak in the sunlight. But why does the love plant do this? Well, it's all about survival. The open leaves absorb sunlight, a crucial ingredient for photosynthesis, the process by which plants create their food. But as the sun sets and darkness encroaches, the love plant does something rather peculiar. Its leaves fold back up, as though it's tucking itself in for the night. Now let's turn our attention to the morning glory. This plant, with its trumpet-shaped flowers in shades of blue, pink and white, is a sight for sore eyes. But its beauty isn't its only claim to fame. Morning glories, true to their name, bloom in the early morning. They unfurl their petals in an elegant display, welcoming the day with open arms. But as the day wears on and evening approaches, the morning glory starts to wind down. Its vibrant blooms close up, almost like it's saying goodbye to the day. This behavior, much like that of the love plant, is a survival tactic. By closing its flowers at night, the morning glory protects its delicate inner parts from nighttime predators and harsh weather conditions. So what's the common thread here? Both these plants move to the rhythm of the sun. They dance their day-night dance, each movement a step towards survival. They open to soak up sunlight and close to conserve energy and protect themselves. It's a delicate balance, a dance choreographed by nature itself. Just like us, these plants have their own daily routines. They truly are nature's day-night dancers. So, as we've seen, plants move for a variety of reasons. They're not just static entities confined to one spot, but active participants in their own survival and propagation. Their movements, while subtle to our eyes, are a testament to the intricate and fascinating world of botanical motion. Let's take a moment to recap what we've learned. We started with the Venus flytrap, that famous hunter of the plant kingdom. Its rapid insect-catching ability is a startling example of plant motion. This carnivorous plant's movement isn't just for show, it's a survival strategy, allowing it to supplement its nutrient intake in nutrient-poor environments. Then we shifted our gaze to the sunflowers, those radiant sun chasers. Sunflowers perform a daily dance, turning their heads to follow the sun's path across the sky. This heliotropic movement, as we've learned, aids in maximizing the plant's exposure to sunlight, and thus its ability to photosynthesize efficiently. We then explored the day-night dancers, the love plant, and morning glories. The love plant, or purple shamrock, opens during the day and closes at night, while the morning glories live up to their names, blooming brightly each morning, only to close up by night. These rhythmic movements are their response to the changing light conditions, a phenomenon known as nyctinisty. Finally, we touched on the sensitive plant, which reacts to touch by closing its leaves. This thigmonastic movement is a protective measure, serving to deter potential predators or environmental harm. All these movements, whether they're for capturing prey, following the sun, responding to light conditions, or avoiding harm, serve critical functions for these plants. They help the plants to find water and nutrients, spread their seeds, protect themselves, and ultimately to survive and thrive. The next time you see a plant, remember, it might be more active than you think.